Hello all, good evening. Welcome back to my YouTube channel all about VLSI. Hope you're all doing good. Right. I hope my voice is audible and my screen is also visible. Right? Yeah. So welcome back. So today we are going to discuss about product of sums in Boolean algebra. So in our previous session, we have completed our discussion about sum of products, and in this session, we are going to discuss about product of sums. Okay. So if you haven't watched the previous video, please go back and please rewatch it because it is needed for this we to understand this particular product. Understand this particular video, POS. Okay, product of sums. We have discussed already SOP. Okay, yeah. So let us start today's session. Wait a minute. Yes. So let me open my presentation. Yeah. So we will start with the topic called product of sums. That is POS form of representation. POS form of representation. So in previous session we have discussed it with SOP form of representation. Now we are going to discuss about what is meant by POS form of representation. Okay. Yeah. So in POS form of representation, each term of product of if each term of product of sum contains all the variables, uh, sorry. So we have already seen what is meant by POS term. For example, product of sum is nothing but, let's say, A plus B plus D into B plus C plus, let's say, E. Here the product, the sum is getting multiplied. Here the sum terms are getting multiplied. So in this POS form of representation, the sum terms are getting multiplied. So this is the example of POS. In the previous session also we have seen the introduction of POS form. Okay. Now we will start with what is meant by standard or canonical form, canonical POS form. Okay. What is meant by standard or canonical POS form? Okay, what is meant by standard or canonical POS form? What is this standard or canonical form of POS? For example, if we have a function of variables a, b, c, d, function of a, b, c, d. So it is a function of the variables a, b, c, d, which is equal to, let's say it is equal to a plus b plus c bar plus d into a bar plus b plus c bar plus d. Okay. So in this function, if we observe, each and every literal is present. A is present, B is present, C is present, D is present. Here also each and every literal is present in this function. So this type of function is called standard or canonical form, POS form. Okay, so if each and every literal is present in a particular function, then it is known as a canonical POS form. In SOP also we have seen, where if each and every literal is present in a function, then it is known as canonical SOP form. In SOP form we have seen. In the POS form also same like that. If each and every literal is present in that particular function, then it is called as standard or canonical POS form. Okay, so this is about standard or canonical POS form. Now in this POS form, like SOP, like in SOP where we have min terms, in POS we have max terms. We have max terms. Okay, so what are these max terms? Each sum term in standard POS form is known as max term. I will write it here. Each sum term in standard SOP form. Remember this keyword, focus on this keyword, standard SOP form, not normal SOP, sorry, not normal standard POS form, normal POS form. It is standard POS form. not normal standard P, not normal POS form, it is standard POS form. Okay, is called as max term. Okay, so I'm focusing on this point standard. So each sum term in the standard POS form is called as max term. Okay. For example, for an n variable function, there will be 2 power n max terms. Let's say if a function is of 3 variable, then how many max terms are possible for this? 2 power 3, which is equal to 8 max terms. 8 max terms. Okay. So for n variable function, there will be total 2 power n max terms. 2 power n max terms. Okay. So this is about max terms. And a max term assumes the value of 0 only for one combination of variables. Okay. A max term assumes the value of 0 only for one combination of variables. Whereas in case of minterm, we have seen a minterm will assume the value of 1 only for one combination of variables. If you remember in our previous session also we have discussed this. So here in the case of max term, it will assume the value of 0 only for one combination of variables. For example, if we have a plus b plus c plus d bar. Let's say this is a 4 variable function and this is our max term. Okay, this is our max term. So it will be equal to 0 only for one combination. That is, a is equal to 0, b is equal to 0, c is equal to 0 and d is equal to 1. So only for this particular combination, this particular max term will be equal to 0. Only for one combination of A, B, C and D, this particular max term will be equal to 0. No other combination is possible. Let's say suppose if A is equal to 1, then this particular max term cannot be 0. Okay. So that is what it is said. Okay. So only for one combination of max term, only for one combination of A, B, C, D values, the max term will be equal to 0. Whereas in case of minterm, only for one combination of A, B, C, D, the minterm will be equal to 1. Okay, that we have already seen in our previous session. And the product of max terms whose value is 0 gives the standard or canonical form of function. And max terms are represented by capital letters. For example, M0, capital M0, capital M1, capital M2, capital M3. So these are our max terms. So this is how we are going to represent our max terms. Okay, where the subscripts denote the decimal equivalent of the binary number. Okay, in min terms also we have seen the subscript represents the decimal equivalent of the particular binary number. So for max terms, the binary words are formed by representing each non-complemented variable by 0 and each complemented variable by 1. So in max terms, binary words are formed by, so binary words here in the case of max terms, binary words are formed by representing non-complemented variable by 0, and complemented variable, wait a minute. Yeah, so and complemented variable by 1. Complemented variable by 1. Here the non-complemented variables are 0 and complemented variable by 1. For example, if we have a max term, let's say A plus B bar plus C bar plus D, then the binary equivalent for this max term is nothing but, so A is, so 0 is represented by non-complemented variable and 1 is represented by complemented variable. So B bar is 1. C bar is 1 and D is 0. That is what I have written here. So binary words are formed by representing non-complemented variables by 0. Here non-complemented variables are equal to 0, whereas complemented variables are equal to 1. Here the complemented variables are equal to 1 and non-complemented variables are equal to 0. Okay, whereas in case of minterms, the complemented variables are 0 and non-complemented variables are 1. That we have already seen. And this is equal to capital M6. Capital M6. So this is the max term for this particular Boolean expression. Okay. Now let us see the possible combinations. For example, if we have three variable function a, b, c, let us write the max term corresponding to that. So what are the possible combinations for three variable function ABC? So 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, double 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Total how many combinations? 1, 2, 3, 4, 5, 6, 7, 8. 8 combinations are present. And for this particular, what is the max term related to it? So 0 is represented as non-complemented form. Non-complemented form, that is A plus B plus C. Product of sum. Okay. It is represented as product of sum, not SOP, POS form. Max terms are related to POS form. And here it is nothing but A plus B plus C bar. Here A plus B bar plus C. And here A plus B bar plus C bar, followed by A bar plus B plus C, and A bar plus B plus C bar, and A bar plus B bar plus C, and here A bar plus B bar plus C bar. So these are the max terms related to the following, corresponding to the following binary numbers. So this indication will be equal to M0. It can be represented as capital M0, M1, M2, M3, M4, M5, M6 and M7. So this is how we are going to write all the max terms in the POS form of representations. Okay. Yeah. Next, let us see the notation of this max terms. So we use pi notation. We use this type of notation for representing the max terms. For example, if we have a function f of a, b, c, which is equal to a plus b plus c into a bar plus b plus c into a bar plus b bar plus c plus c. This function, let's say if we have, and so this function can also be represented as f of a, b, c can be represented as m naught. So a, b, c, from the table if you observe, a plus b plus c is nothing but m naught. A plus b plus c is nothing but m naught. So m naught into a bar plus b plus c can be represented as m1 b plus c. A bar plus b plus c. It can be represented as, it is represented as m4. It is represented as m4 plus m6. So this is how we can represent the Boolean function. Okay, m0 into naught plus here multiplication. m0 into m4 into m6. So this is how we are going to represent in the form of max terms. And we can also represent in one more way, that is f of a comma b comma c can be represented as pi of 0, 4, 6. So this is one more way of representing our POS form. Okay. So this is how we can represent our POS form in the terms of max terms. Okay. Now let us see how to convert POS form to standard POS form. Okay. So we have already seen what is meant by standard POS form. Let us say if we have a function, f of a comma b comma c, which is equal to a plus b bar plus c into c bar. Okay, so is this a standard POS form? Can anyone answer this? Is this a standard POS form? No, this is not a standard POS form. Why it is not a standard POS form? If you observe in each and every term, here, here in the first term, A is present, but the two literals B and C are absent. And in the second term, if you observe A and C are absent, and in the third term, A and B are absent. So that's why it is not a standard canonical POS form. So how to convert this into standard canonical POS form? So we should identify what are all the missing literals in each term. Okay, so we have to identify what are all the missing literals. So first step is to identify the missing literals in each term. So we have to identify the missing literals in each term, and we have to, so after finding out, so if one or more variables are missing in any term, expand that term by adding the products of each term missing variables and its complement. For example, for expanding, we can use this particular rule. For example, if we have a plus bc, how can you solve this? How can you expand this? It can be expanded as a plus b into a plus c. This we have already seen in our previous sessions. So if we have a function, let's say a plus bc, then how can you expand this? It is not a standard canonical form. A plus bc is not a standard canonical form. Why? Because the first term is missing the b, and the second term is missing the term a. So how to expand this? You can expand this using a plus b into a plus c. Similarly, in our example where we are having a plus b bar plus c into c bar, how can you expand this? You can expand this by using the same concept. So how can you expand this? A plus b bar plus c into a plus b bar plus c bar, a plus b bar plus c bar. So this is the standard canonical form. Standard canonical POS form. Standard canonical POS form. So this is how you are going to convert normal POS form to standard canonical POS form. Okay, I hope this is clear. Now let us see how to convert standard SOP form to standard POS form. Now let's see conversion of standard SOP form to standard POS form. Let us see this conversion, how to convert this standard SOP form to standard POS form. So the complement of a function expressed as sum of minterms is equal to sum of minterms missing from the original function. This is because the original function is expressed by those minterms that makes the function equal to 1, whereas its complement is a 1 for those minterms that makes the function equal to 0. For example, let us consider this example. Let's say if a function f of a comma b comma c is present, and it is represented in standard SOP form. Okay, standard SOP form. Let's say it is equal to 1267. 1267. We have a SOP form like this, or it also can be represented as M1 plus M2 plus M6 plus M7. Okay, this is also represented like this. Now, how to write it in Boolean form, or what is another way to represent this? M1 can be represented as A bar, B bar, C. This we have already seen. And 2 can be represented as A bar, B, C bar. And 6 can be represented as A, B, C bar, plus 7 can be represented as A, B, C. Okay. So this is how we can represent the particular minterms. Okay. So after incorporating the missing minterm numbers in the original function, we can get the complement of the function f of a, b, c, which can be given as, for example, f bar of abc. So how to find the complement of this particular function f of abc, which is nothing but f bar of a, b, c, can be written as sigma of 0, 3, 4, 5. How I am writing this? So in the starting I said a statement, the complement of a function expressed as sum of min terms missing from the original function. I will write it here. So I have made a statement. What is that statement? The complement of a function. How to find the complement of a function? The complement of a function expressed as sum of min terms. Sum of min terms is equals to sum of min terms missing in the original function. Missing in the original function. Missing in the original function. Okay, so this is how we are going to find the complement of a function. So the complement is of a function which is expressed as a sum of min terms is equal to sum of min terms missing in the original function. So if a function f of abc is given as m1, m2, m6, m7, then how to find the complement of that particular function? You will write down the missing terms in that particular function. So 1, 2, 6, 7 are present in that particular function. So what are the missing terms? 0, 3, 4, 5 are the missing terms. So f bar of abc is nothing but 0, 3, 4, 5. So this is what the complement of a function. 0, 3, 4, 5 is the complement of the function. So how to write the min terms for this? Which is nothing but m0 plus m3 plus m4 plus m5. And how to write the another form of representation, which is nothing but a bar, b bar, c bar plus a bar, b, c plus, and we have a, b bar, c bar plus a, b bar, c. So this is how we are going to write another form of representation. Okay, now if we take the complement of f bar, we get f. So if I apply complement of f bar, then I will get f. So if I take double complement, so if I take double complement here, so double complement gets cancelled and I will get complement here. Okay, so that is what I am going to write. F of a comma b comma c, which is equal to m0 plus m3 plus m4 plus m5, the bar. m0 plus m3 plus m4 plus m5, the bar. This is what I am getting. Now if I apply De Morgan's law, what I will get? F of a, b comma c can be written as m0 3 bar into m4 bar into m5 bar. Okay, next. So writing the standard POS term corresponding to each min term, we will get f of a comma b comma c can be written as a bar, b bar, c bar whole bar into a bar, b, c the bar into a, b bar, c the bar, a, b bar, c bar the bar into a, b bar, c the bar. Okay. Now if we apply De Morgan's law, again what we'll get? F of a comma b comma c can be written as a plus b plus c into, so if you apply De Morgan's law here, you will get the thing a plus b plus c. It is similarly nothing but x bar into y bar, which is nothing but x plus y the whole bar. That's it. Okay, here I think we have one more common. Yeah, x plus y the whole bar. Okay, so it will become a plus b plus c into a plus b bar plus c bar into a bar plus b plus c into a bar plus b plus c bar. So if you observe, these are nothing but our max terms, which is nothing but our max terms m0, m3, m4 and m5, which is nothing but pi of 0, 3, 4, 5. Pi of 0, 3, 4, 5. So from this, what can we conclude? From this, what can we conclude? What is our conclusion? Which is nothing but the min terms, the complement of min term is nothing but max term. So it can be stated that max term complement is the min term and vice versa. So if we complement a min term, m of j bar can be equal to capital M of j. So the max term complement is the min term and vice versa. That is max term, sorry, mj bar is equal to mj. The complement of min term is equal to max term, or complement of max term is equal to min term. So for, let's say, if we have a function f of a, b, c, which is equal to 0, 1, 4, 7. So how to find the max term of this particular function, which is nothing but f of a comma b comma c pi of 2, 3, 5, 6. You can just simply write the missing terms in the min max term. We'll get the max term. That's it. Okay. So this is how we are going to convert min term to max term and max term to min term. Okay. So this is about the POS form and SOP form in Boolean algebra, and how to convert a POS form to SOP form and SOP form to POS form. Okay. Yeah. So that's all for this session. So if you're having any doubts or queries, you can ask me, or else we can end this session. Thank you.